Hello students, welcome to my channel. In this channel, we are going to discuss the various topics, subtopics of the ICSE physics syllabus. Now, the very first topic of the first chapter is moment of a force or torque. Now, let's try to understand this. Now, one of the effects of force is that force can start or stop motion. Meaning, if a body is lying at rest, we apply force to it, the body moves from one place to another. The force produces what is known as translational motion. Okay. The second type of motion produced by force is, say it's a guitar string which has been clamped at the two ends. We apply force to it. The force will produce what is known as vibrational motion, to and fro motion. The third type of motion that force can produce is, say the same body was clamped here. A nail had been fixed, or it has just been clamped, or like how I'm holding it with my fingers. Now when I apply force to it, the force will produce what is known as rotational motion. Okay. Now this third type of motion, rotational motion, is there in our syllabus, and moment of a force means the turning effect of force produced on a body which is free to rotate about an axis. Now here where I'm holding it, this is the axis, and we are trying to understand now how much turning effect or how much torque will the force produce. Now let's go deeper into it. Supposing here's the body, okay, and this is where the nail has been fixed, or like how I was holding it with my fingers. Now this is called the axis of rotation. So I put a mark O there. This is called the axis of rotation. It could be a regular body, irregular body. Okay, please clear that doubt from your mind. Now this is where, supposing I apply force to this object. Now when I apply force to it, this body is going to rotate. Now I take a dotted line upwards. This is called the line of action of the force. From the axis of rotation, now I draw a perpendicular 90 degrees to the line of action of the force. Okay, 90 degrees here. And I mark this distance as d. Now, the moment of a force or the turning effect of force is the product of the force and this perpendicular distance between the axis of rotation and line of action of the force. So if I have to write it, let me use the shorter version. Torque or moment of a force is the product of force applied and the perpendicular distance from the axis of rotation and the line of action of the force. So this product gives us the turning produced. We have to understand this a little bit more in detail now. Then what will its unit be? Now the SI unit will be the SI unit of force multiplied by the SI unit of distance. So the SI unit becomes Newton for force and meter for distance multiplied Newton meter. Okay, this is the SI unit. Now here, this is the formula which we are going to use for all our mathematical numericals and all sums. Okay, now here are certain doubts which I want to clear. First of all, the major confusion with the students is that the axis of rotation is a point. It's not a point. It's an imaginary line along which the body rotates. Like in geography, we know the axis, the Earth's axis. It is an imaginary line. Okay, it's not just a point. So here, though I've shown it with a point, the axis of rotation will be going into the board or outside the board. This is an imaginary line here. Supposing it's a book. Say we have a book like this. Here is a book. Now, when I apply force to it, there is turning produced. Okay, I'm opening it. So now where will the axis of rotation be? Here. This is the axis of rotation. So that is one thing which we have to be very clear about. Now, the perpendicular distance. Okay. Now here again, supposing I have this body, again, I'm using the same object as an example. This is my axis of rotation. There has to be a perpendicular distance between the axis of rotation and where I apply the force for turning to be produced. See, it turned. Now, if I was to apply force at the axis of rotation, this body will not turn. Here also it will not turn. Here also it will not turn. Here also it will not turn. Why? Because there is no perpendicular distance. So there has to be a perpendicular distance for a body to rotate, okay, between the axis of rotation and line of action of the force. So that also you keep in mind. Then, as we can see, two major factors contribute to the turning produced. You apply stronger force, obviously the turning will be greater. You apply a weak force, the turning will be less. Then the perpendicular distance. The greater the perpendicular distance, more will be the turning produced. If I was to apply the force somewhere closer to the axis of rotation, the turning would be less. If I apply it further away, the turning will be more. And there are real life examples based on this. You know, doors. When you look at a door, supposing here's the handle, here's the hinges, okay. This is your axis of rotation, the hinges. The door handles are fitted furthest away from the hinges so that the distance increases. The perpendicular distance increases. And so with minimal force, you can open and close the door. You know, the torque produced is greater in that case. If you had the handles closer to the hinges, you'd have to apply more force to open the door. If the handle has been placed on the hinge, there'll be no turning produced. You can be very strong, you apply a lot of force, you'll break the door, but it will not produce any turning because D is 0. So this is a major factor. Another example where D is increased to produce more turning effect is in spanners, wrenches. Now, if you have to open a bolt with a small wrench and you are given a bigger wrench, the longer one will be more effective. Why? Because in the first case, okay, here you are applying force, so the distance is small. Since the distance is small, the torque produced is less. You'll literally have to struggle trying to open this nut. Whereas in the second case, again, here's the force. Now the distance has increased. So here you are getting more torque. You know, especially car wrenches, when you experience a tire puncture, if the wrench is not of a decent length, you notice if it's small, especially small vehicles have small wrenches. You have seen parents literally climb over it. You know, you have to use your leg and all your body weight to try and open the nut. So greater the distance, more will be the torque produced. Another example of this will be on grinding stones. You have noticed grinding stones, there are two circular stones, one on the top and one at the bottom. The top one has a handle, and here's the hole where you put your pulses and all those things. The handle is always towards the rim. Why towards the rim? Because now that you have increased the distance from the axis of rotation, you have increased this distance. So your torque produced will be more. You cannot have it closer towards the center, the torque will be less and you'll have to apply a lot of force to turn it in that case. So to increase torque, it has to be furthest away. Potters, when they are doing their pottery, they carry a stick with them, they keep a stick, they'll always hit at the edge so that the torque increases. It becomes easier to spin the wheel. All right. So all these are examples where torque can be increased by increasing the perpendicular distance between the axis of rotation and line of action of the force. Okay. Now, let's try to understand this formula a little more in detail. So the formula says F into D. Now say we apply a force of 10 Newton, okay, and this distance between the line of action of the force and the axis of rotation is 2 meters. So how much torque is produced in this case? So torque produced is F into D, so that is 10 multiplied by distance is 2, so that is 20 Newton meter. Okay. So 20 Newton meter of torque is produced, which will cause the body to rotate anti-clockwise. Now supposing I was to apply another force at the other end now, supposing here. And the force I'm applying here is say 20 Newton, stronger force here. And this distance from the axis of rotation was 1 meter. Now in this case, the torque produced is again F into D. So we have 20 Newton multiplied by 1 meter. So it gives us an answer of 20 Newton meter. Okay. But here the torque produced is clockwise. So in this case it is clockwise. Whereas the previous case it was anti-clockwise. So since there is anti-clockwise 20 Newton meter, clockwise 20 Newton meter, will this body rotate? No, it will not rotate. They cancel out each other. All right. So movement of a force is a vector quantity. And also keep in mind, there is a sign convention. The sign convention tells us that anti-clockwise movement will be taken positive and clockwise movement is taken as negative. Okay. This is the sign convention. Okay. So please keep these things in mind. This will be the, the formula for finding the numericals. Keep in mind that that moment of a force is a vector quantity. Okay. The sign convention is anti-clockwise movement is taken as positive. Clockwise movement is taken as negative. Okay. Now, I want to put up a question for you all. Okay. Say here, this is the axis of rotation, and there are three forces being applied. One here, F1, one here, F2, and one here, F3. So there are three forces being applied on this body. Please write in the comment section which force produces the maximum moment. So this is one. And which force produces minimum moment. All right. So you can write this in the comment section. I'll be replying to most of the queries there. Thank you. Please do like the channel if you feel it's been useful to you.